Right now you can see things you'll never reach. They're not just far away. They're gone, on the far side of a line you can't cross. We like to think the universe is out there, waiting, that with a fast enough ship and enough time you could go anywhere. Touch any of those lights. You can't. Most of them are already beyond us, and every second more of them slip away. So let's start with a simple question. How big is the universe? Most people do the obvious math. The universe is 13.8 billion years old. Light is the fastest thing there is. So the universe should be about 13.8 billion light years across. Maybe double that, if you measure edge to edge. That answer feels right. It's clean, it's logical, and it's wrong by a factor of almost 7. The observable universe is not 14 billion light years across. It's about 93 billion. 93 billion light years of space, grown in only 13.8 billion years of time. Nothing in it moved faster than light, and yet here we are, staring at a number that shouldn't fit. Here's the thing. That gap isn't a rounding error. It's the first clue that the map of the universe in your head, the one you've trusted your whole life, is wrong. Not slightly wrong. Wrong about what big even means. Wrong about where the edge is, and wrong about how much of it you're allowed to keep. So let's take that number apart. And by the end, the size won't be the scary part. Start with the obvious objection. If nothing travels faster than light, how can anything be 46 billion light years away after only 13.8 billion years? The answer is that the galaxies aren't the ones doing the running. Space is. Think of 2 dots drawn on a balloon. You don't move the dots. You inflate the balloon. The dots stay put on the rubber, but the rubber between them grows, so they drift apart. Blow it up fast enough and 2 dots can separate faster than either one could ever crawl across the surface. That's our universe. Galaxies mostly sit still in their own patch of space. But the space between them stretches, and space has no speed limit. The rule that nothing beats light only applies to things moving through space, not to space itself pulling apart. And this is the part people miss. Space doesn't expand at a speed. It expands at a speed per distance. Every stretch of the universe grows a little each second. So the more space there is between you and something, the faster it pulls away. Nearby galaxies drift off gently. But go far enough out, add up enough stretching space, and the total can climb past the speed of light. Not because anything is racing, just because there's that much space between you, and all of it is growing at once. So, there's a distance, cosmologists call it the Hubble sphere, beyond which galaxies are already receding faster than light. And here's the twist that breaks people's brains. We can still see some of them. Their light was sent long ago, when they were closer, and it's been swimming upstream against the expansion ever since, losing ground, but still, barely, gaining on us. Every photon from the deep universe is a survivor of a current that was trying to sweep it away. So when a galaxy sends light toward us, that light crawls across the space in front of it at its fixed speed. But behind it and around it, new space keeps unfolding. By the time the light arrives, after maybe 13 billion years, the galaxy that sent it has been carried much farther out. It's now around 46 billion light years away. We're seeing a ghost, a postcard from a place that has since drifted 3 times deeper into the dark. Look up, and you're not seeing the universe as it is. You're seeing where things were, lit by light that barely made it here in time. And some of that light barely made it for a reason we'll get to, because the ground it was running on was trying to outrun it. So if space keeps stretching, the universe should just fade away smoothly in every direction. Fainter and fainter, forever. Point a big enough telescope, wait long enough, and you'd eventually see all of it. Except you can't. There's a wall. And the wall is not made of anything you'd expect. Look far enough in any direction and you hit the same thing. A faint glow, coming from everywhere at once. That glow is the cosmic microwave background. It's the oldest light in existence, and it is the farthest any telescope will ever see. So what is it? For its first 380,000 years, the universe was too hot for atoms to hold together. It was a fog of raw plasma, and light can't travel through fog like that. It just bounces, trapped. Then the universe cooled enough for atoms to form. The fog cleared in an instant, and that first freed light has been flying ever since. We still catch it today, stretched and cooled into a whisper of microwaves, and this is where your picture of the edge falls apart. That wall isn't the edge of space. It's the edge of time. We're not seeing the boundary of the universe. We're seeing as far back as light itself is allowed to come from. Beyond it, there's more universe. We just can't see it, because back there the universe hadn't switched the lights on yet. So, the edge of the observable universe isn't a place. You could never fly to it and find a wall. It's a horizon. The distance light has had time to cross, and a horizon moves with you, which means every galaxy out there has its own. Somewhere far away, something is looking back in our direction, and we are the faint glow at the edge of what it can see. Now let's do the opposite of looking outward. Let's zoom out on ourselves and find out where you actually live. You start here, Earth, one rock, around one star. Pull back, and the sun becomes one of maybe 200 billion stars in the Milky Way. If the sun were a grain of sand, the galaxy would still be wider than an ocean. Pull back again. The Milky Way isn't alone, it's part of the local group, a small huddle of about 50 galaxies. Then the local group turns out to be a suburb of the Virgo cluster. And Virgo is just one node in something with a name that finally sounds as big as it is. Laniakea, our supercluster. 100,000 galaxies, flowing together across 500 million light-years of space. That's your address. Not your street, not your country, not your planet. 100,000 galaxies, and it's the local neighborhood. And Laniakea isn't just a clump. It's a flow. The astronomers who mapped it in 2014 defined it by motion. They tracked which way galaxies are drifting and drew the border where the current changes direction. Everything inside is falling, slowly, toward a single deep point they call the Great Attractor. The name Laniakea means immeasurable heaven. 100,000 galaxies, all sliding toward a gravitational drain we can't even see clearly, because our own galaxy is sitting in the way. And in 2024, astronomers found hints that even Laniakea might just be an outer arm of something bigger still, pulled toward a distant giant called the Shapley concentration. Our supercluster, the thing 100,000 galaxies wide, may itself be a suburb. Every time you think you've found the edge of big, it turns out to be a doorstep. Zoom out one more level, and the whole universe shows its true shape. It isn't galaxies scattered at random like sand. It's a web. Galaxies string together along glowing threads called filaments. Between the threads sit voids, vast, near-empty bubbles, hundreds of millions of light-years away, where almost nothing exists at all. The whole cosmos looks like foam, or the inside of a brain. Bright walls of galaxies wrapped around enormous pockets of nothing. Some of those walls are almost too big to be real. The Sloan Great Wall is a sheet of galaxies more than 1 billion light-years long, and structures even larger have been proposed, so large that some cosmologists argue they shouldn't be able to exist at all, because the universe hasn't had time to build them. That argument is still open, but the pattern is not in doubt. At the largest scale, Everything you've ever seen is one bright thread in an endless dark web, and the threads are the exception. Most of the universe is the empty part. If you dropped into the middle of one of those voids, you could travel in a straight line for 100 million years, at the speed of light, and pass nothing. No star, no galaxy, just black in every direction, so complete that an astronomer born there might never suspect anything else exists. The bright web we marvel at is a lace curtain hung over an ocean of nothing. So let's answer the question we started with. How big is the universe? Try to shrink it down. Imagine the entire observable universe squeezed to the size of a single coin in your palm. On that scale, the Milky Way, 200 billion stars, 100,000 light-years wide, isn't a speck. It's smaller than a mote of dust about the width of a single virus. And you, your planet, your whole solar system would be gone long before that. That is the size of the thing we live inside. And remember, the coin is only the part we can see, and that web has been quietly growing this whole time, which brings us to the force pulling it apart, and the reason this story turns from wonder to something colder. In 1998, two teams of astronomers were measuring how fast the universe's expansion was slowing down. Gravity pulls. Everything attracts everything, so the expansion had to be losing steam. They were just arguing over how much. They got the sign wrong. It wasn't slowing down. It was speeding up. The expansion of the universe is accelerating. Something is pushing space apart harder and harder every year. Two rival teams founded at the same time, chasing the light of exploding stars halfway across the cosmos. And both got the same impossible result. The distant supernovae were dimmer, farther than a slowing universe could explain. The expansion had a foot on the gas. We don't know what the foot is. We can measure it. We can put it in the equations. We handed out a Nobel Prize for finding it, and we still just call it dark energy, which is a scientist's honest way of admitting we have a name for a thing we can't explain. And it is not a minor ingredient. By the numbers, this stuff we can't identify makes up around 68% of everything in the universe. The galaxies, the stars, the planets, all of that is a thin film on top. The main event is an invisible pressure with no known source, and it is winning. And an accelerating expansion changes everything about that number we started with. Because if space is pulling apart faster and faster, then somewhere out there is a distance where it's pulling apart faster than light can fight back. A line where galaxies are being carried away so fast that nothing they send, no light, no signal, nothing, will ever reach us again. That line has a name, and crossing it is forever. It's called the cosmic event horizon. Not the kind around a black hole, the kind around all of us. It's the distance beyond which the expansion of space wins permanently. A galaxy that crosses it doesn't disappear in a flash. It just fades and reddens and slows, and its last light stretches out thinner and thinner until the universe goes quiet where it used to be. And here is the fact that should stop you. Most of the galaxies you can see tonight are already past it. Think about that. We can still see them, their old light is still arriving, the postcard is still in the mail, but the galaxies themselves have already been carried beyond the line. If you launched a ship at them right now, at the speed of light, you would never arrive. Ever. Put a number on it. Telescopes can see something like 200 billion galaxies, maybe more, but of all of them, only the closest few percent are still reachable, the ones inside that shrinking bubble where light can still fight the expansion and win. Every other galaxy in the sky, the overwhelming majority, is scenery. We can photograph it, name it, study its light, and never send so much as a signal that will arrive. Wave at them all you want. The wave never lands, and the bubble is shrinking. Not because we're doing anything wrong, because space between us and them keeps stretching faster. Each year, the reachable universe gets a little smaller, and a few more galaxies slip from someday to never without a sound. We didn't lose them in some catastrophe. We lost them to geometry. Quietly. The universe is not a place you get to wander. It's a place that is closing. Now run the clock forward. Not thousands of years, billions. As the expansion accelerates, more and more galaxies cross that horizon and wink out of reach. The sky doesn't fill up, it empties. One by one, the distant galaxies redshift into darkness, until the only things left in our sky are the ones gravity has bolted to us. Our own local group, the 50-odd galaxies close enough to hold on, eventually merging into a single island of stars, an astronomer living on that island, trillions of years from now, would look up and see stars, and beyond them, nothing. No other galaxies, no cosmic web, no glow of a beginning. They would have no way of knowing the universe was ever anything but their single galaxy in an empty void. The evidence will have left. They'll do their best science, and they'll be certain, and they'll be wrong. Because the truth will already be over the horizon, which means something strange about right now. We live in a rare, bright window, early enough that the light of the whole universe still reaches us. We can still see the beginning. We can still see the web. We got here in time to know the truth. That window is closing slowly, and it will not reopen. There's one more assumption to take away from you. When you picture all of this, the sphere of what we can see, the horizon in every direction, it feels like we must be sitting at the center of it. We are, and so is everyone else. Every observer, anywhere in the universe, sees themselves at the middle of their own sphere, with their own horizon the same distance away in all directions. That's not because everyone is special. It's because there is no center at all. The Big Bang didn't happen at a point in space you could fly back to. It happened everywhere, to all of space at once. There is no wall, no middle, no outside to stand on and look in. Whichever way you go, the universe just keeps going, and your horizon travels with you. Always the same distance ahead, forever out of reach. So how big is the universe really? Not the part we can see, all of it. So here's where the honesty comes in. We don't know how big the whole thing is, and we might never. We can measure the shape of space itself by looking at that oldest light, the microwave wall, and checking whether its patterns come to us bent or straight. If the universe were curved, those patterns would look distorted, like text through a lens. They don't. Every measurement says the same thing. As far as we can tell, the universe is flat, not curved back on itself like a ball, flat in every direction, to within a tiny fraction of a percent. And a flat universe has a haunting implication. A ball curves back and closes on itself. Walk far enough, and you return. A flat sheet doesn't close. It just goes. So if space really is flat, it may be infinite, endless. Galaxies without end in every direction, forever. The same cosmic web, the same voids and walls, repeating past the horizon and never stopping. If it's not infinite, it's still absurd. One estimate, if the universe curves back on itself far beyond our sight, puts the whole thing at least 250 times bigger than everything we can observe. Which would mean that all of it, every galaxy and every photograph, the entire 93 billion light-year sphere we started with, is less than half of 1% of what's actually out there. That's the real scale of the universe. Not a number, a confession. The honest answer to how big is it is that our map has a hard edge. drawn not by the universe but by the speed of light and the age of time, and the territory beyond it may have no edge at all. And yet we keep pushing the edge back. In 2025, the James Webb Telescope confirmed a galaxy called MOM-Z14. Its light left when the universe was just 280 million years old, barely 2% of its current age. We are now looking almost all the way back to the first light. And what we find back there doesn't match our models. When Webb looked, it found galaxies in the infant universe that are too bright, too grown up, too soon. Some of them 100 times more luminous than the theories predicted anything could be that early. It's as if the cosmos was building faster than the rules allow, lighting fires before there was supposed to be fuel. We spent decades sure we knew how the first galaxies switched on. We reached the edge of what we could see, and the edge handed us a mystery instead of a confirmation, and it keeps happening. Every couple of years, a new, most distant galaxy is confirmed, each one deeper into the dawn, each one a little stranger than it should be. That's the shape of this whole story. Every horizon we cross, the light barrier, the microwave wall, the earliest galaxy, turns out to be the doorstep of a bigger room we can't enter yet. The map keeps getting larger at the exact edge where we thought it would end. So, look up again. At those lights you can never reach. They were never yours to keep. Some of them are already gone, carried past a line you cannot cross, and one by one the rest will follow. You were born into a cosmos that is quietly leaving, into a view from a window that is sliding shut. But you're here now, in the bright, brief window, when the whole thing is still visible, when the light of the beginning still reaches your eyes. You got here in time to know how big the universe is, and how much of it you'll lose. The map in your head had an edge, and a middle, and a size you could name. The real universe has none of those. It has a horizon that runs when you chase it, a center that sits everywhere at once, and a size we may never have a number for, infinite, or close enough that it will never matter. That's as far as this one goes, but the edge always moves. This is a Philo. Subscribe, drop a like if it earned it, and your next one's on screen now. I'll meet you a little further out.